Hello, everyone, and welcome to the first session of our Talk Tech series. Before we begin, I have a few quick announcements. This session is being recorded, and the recording will be sent out to all participants after the session is concluded. If you have any questions, please submit them using the Q&A feature in the Zoom platform or by typing them into the chat box. We'll answer them at the end of the session. With that out of the way, let's go ahead and get started.
Hello and good afternoon. I'm Andrew Jacobs, and if you're here to learn about modern logistics in government, then congratulations, you're in the right place. So today we are going to be talking about the importance of real-time data. So here's our agenda. We're going to start off just with some definitions, and then we'll jump into some examples and try and figure out what is the common thread that made them successful. Then I'll propose what I think the key to effective logistics is, and then we can talk about event streaming with Apache Kafka and Confluent. We'll look at some government case studies, and if you're interested, we can talk about how you would get started with this, and then dive into some Q&A. So hopefully that is of interest to you all. And if you have questions, please feel free to put them in the chat. We'll deal with them at the end of the presentation. All right, so diving right in, what is supply chain management and logistics? And if you've ever needed to buy anything, supply chain management is the thing that starts with the raw materials and ends up with that product that you want in your hands. And it covers everything in between. So it's a huge field, and logistics is a smaller portion of supply chain management that focuses on getting the right things to the right place at the right time. You can see in the right condition at the right cost too. So there are some other factors. I'm not going to be a stickler for making the difference between supply chain management and logistics. We'll kind of cover them both together, but they are extremely important. And I've listed a few examples here of how logistics are already being leveraged in the government today. So you can think of natural disasters and what FEMA has to do to come in to be able to help those who have been affected. You can think about public health and pandemics, that we have all lived through, and how important it is to make sure that you have the right equipment, like ventilators, PPEs, vaccines, to be made available. You can look at it from a military standpoint, and how can you have operational readiness for the military, so you have the right personnel with the right equipment, with the right supplies, and the right parts. All of that gets extremely complex in order to successfully fulfill that mission. Just quick aside, I've been reading a little bit about Normandy in World War II, and the fascinating part that I didn't realize is a lot of the German soldiers there lost their faith in their ability to win that war when they saw the logistical superiority of the Americans, because we came in and we had so much equipment, and if any of it broke or was shot down, there was something right behind to take its place. The soldiers had their own food that they carried instead of having to go steal it from the nearby villages. So I'll leave it there, but logistics can have a huge impact on things like that. So a few other examples, you can look at CBP. They obviously have a bunch of cargo and shipping containers that they have to look through, and they have to determine which of those are high risk that need a closer look without slowing down the lower risk shipments for all of the things that we purchase. DoD, NOAA have space satellites that they need to get. In fact, Deep Space Net information has a bunch of telemetry on how all of that is functioning. It's very critical to have insight into that, as well as transporting prisoners and ensuring that they have everything that they need, that the right supplies are available. This is just a small subset. You all could flesh this out and have a ton more. You could talk about the VA and the hospitals and clinics and the medical supplies that they need there, how the USDA execute its food safety inspections, or Secret Service, with its protective operations, GSA buying equipment. The list goes on and on and on. So logistics, I think it's clear, are very important, but they aren't without challenges, right? So here are four that I kind of came up with, and I wanted to home in on just the technical challenges. And I submit the biggest challenge in logistics today is not having visibility to a trusted source of what is actually happening. So the others are related to this because if you think of the types of data that can give you that sort of visibility, maybe you've got a bunch of sensors. You need to have systems that can take and deal with that data in the quantities that it is being produced. And you need to have systems that are resilient enough to be able to handle all that. Another one is dealing with equipment. So a lot of investments have been made. Some of that is legacy equipment that is still extremely needed and very difficult to replace. But you also have more modern investments, and you have to figure out how to integrate all of these together so that you can have a cohesive solution to be able to execute your mission. And the final thing is the mission is being executed in a bunch of different places. So where does it make the most sense to do your compute? Do you need to have things out at the edge? Do you do them in your own data center? Are you working with a cloud provider or multiple clouds? Are you working with all three of these types of things? And do you need information to be shared across them? Do you have external trading partners that are not a part of any of those things that need to be a part of this? So these are some of the technical challenges of ensuring that you've got a good logistics platform. So let's look at a few examples and try and figure out what are these companies doing that is making them successful. And the first one, probably don't even need to tell you, recognize from the screenshot, is Uber. So at any given point in time, there are hundreds of thousands of drivers out there who are looking to offer a ride. Then you've got all of the riders who are on their apps, trying to be matched up with the drivers. Fares have to be calculated in real time. Surge pricing has to be figured out. The route, the timing, all of these things have to be figured out. Imagine what an app like Uber would be like if they only got their data updated once an hour, once every 5 minutes. Would we use it? Probably not. So having access to real-time information is critical. Walmart's an interesting one because 90% of the population in the US has a Walmart within 10 miles of their home. I think close to 5,000 stores. And we, as consumers, let's be honest, we're pretty demanding, right? We want what we want. And we've kind of been trained by people like Walmart who give us that flexibility to walk into a store, grab what we need, or go to our phone, select things, and then either have it delivered or allow us to pick it up. But in order for them to do that and figure out what's actually in stock so that we're not frustrated when we've ordered something and it goes out of stock is an extremely complicated process. Instacart is perhaps even more challenging than Walmart because instead of just dealing with one company, one set of supply chain to bring your products in, Instacart has to deal with multiple different companies and the same problem, right? You don't want people ordering things that are out of stock. BMW has 30 different manufacturing and production facilities across the globe, and they need to know what's going on in them at any given point in time. So they have to have ubiquitous access to real-time data through a reliable platform that lets them make informed decisions about what's going on so that they can take that information and have it fully integrated with their business, with their supplies and other types of things. And because it's around lunchtime, I figured we'd throw Domino's in here, right? So they're like, I think around 6,000 Domino's pizza locations, twice that globally. And all these stores need to figure out kind of what their capacity plans need to be so that they can be prepared for what's happening. And globally, they need to be able to see what the trends are so that they can guide the business in the right direction. It's also nice that we as consumers, we can log in and we can actually see when our pizza gets in the oven, when it gets out of the oven, so that we can go pick it up and have it be nice and hot for us. So the question is, what do those use cases have in common? And as you're thinking about that, I'll tell you what I did. I went to 5 different large language models and posed this question. What is the most critical thing for an effective logistics system? Took those answers, compiled them together, put it into another one so that it's not biased, and had that one answer it. Curious what your thoughts are. So as you think through that, but this is what OpenAI came back with. And instead of reading it, I'll just get to the point, which is to it, if you believe it, uh, having access to real-time end-to-end visibility, or that shared accurate source of truth, is the most important thing, because nothing else can really happen correctly if you don't have that. So you can't do good planning, you can't have a rapid response to disruptions, you can't coordinate well or communicate well with your suppliers, carriers, warehouses, customers, other people. So again, that rings true to me and brings me to my claim, which is, in order to have effective logistics, you have to have access to real-time data. And looking at the examples that, the few commercial examples that we just chose, I think that is true, right? That data is a fuel that they use to create new types of experiences that we enjoy, and we reward them by giving them our money. But I think government isn't different, right? Data is at the key to how these missions get performed every day. And I think there's an opportunity to create even better experiences to deliver the services or create that mission value by having better access to real-time data. And there are already some really good examples. We'll talk about some today, but I think there's so much more that can be done by looking at that data. And so you may be thinking, okay, Andrew, well, we already have access to data. We get data in real time. We get it from all of our operational applications. So what's going on? And you know what? You're absolutely right. So this graphic kind of shows the 2 different estates that we call them, where you've got your operational applications, which are powering the mission. That's there in green. And those siloed data need to be able to execute what they're supposed to, but they also have to share it, usually with other operational applications, and certainly with the other estate, the analytical estate, right? So that is something that we've figured out how to do, but the answer, unfortunately, is creating these brittle point-to-point connections, either to connect these operational applications to each other, or to take that operational data and share it with the analytical data. And so it becomes very cumbersome, because at the end of the day, the databases that are being used there on the operational side is where that data, the value of that data begins, but it gets locked away there. And so figuring out how to extract that and make better use of that is something that is very challenging. And so I think if you look at organizations, if you look at agencies, there's probably a broad agreement that data needs to be accessible across the organization. And they figured out how to do that by putting the data at rest somewhere in a database, a lake house, something like that, right? And there are existing paradigms for doing that. And so if that is the paradigm, then you have these integrations to be able to take that data from where it landed and put it to other places so that it can be used. But fundamentally, there's this construct that when data gets created and it's put at rest, it sits there and waits until something, some sort of a process, comes and interacts with that data. And Forrester's looked at this. They came up with this graphic, which I think explain something that's intuitive to all of us. This graphic shows that the real-time data, the fresher data is, the more valuable it is. So the older data is, the less valuable it is. And so if you have a real-time data platform for the enterprise, that can make a huge difference in making that data accessible so that you can make those time-critical decisions to interact on whatever you're learning from that data. And it's interesting to think about that concept from the lens of everything that's happening with Gen AI, which is all the rage today, right? Because if you think about it, Gen AI can do a bunch of great things, but if you want to have Gen AI powered solutions for your agency, you have to have access to the right internal information about things. So this slide has, an example of um, like a text bot, chat bot that is from an airline, and someone's trying to rebook something. And so if they rebook, they need to rebook. What do you need access to? Well, you need to know who the person is, what flight they were on, where they're trying to go, what other options there are, what the status of all those things are. So a bunch of proprietary information about your logistical operations need to be fed in to that LLM in order to provide the right experience, right? So you have to have a system that can create the right context with the right quality of data that makes it accessible in real time so that you're not giving someone bad information on data that is 5 minutes old, an hour old, or something like that. And so I think the key takeaway here is as an industry, we're really good at focusing on data at rest and having a solution at the enterprise for that. We're less good at thinking about an equivalent solution for dealing with data in motion for the enterprise and making that available to unlock that data so that it can go wherever it needs to go. And that is where event streaming comes in. So we're going to talk a little bit about Apache Kafka and Confluent, which are solutions that provide this real-time data streaming platform. And at the foundation of all of this is data. Now, we talk about that data as an event. And an event, very easy to understand, something happened, right? So you think about your agency, what they do, any kind of thing that happened that needs to be recorded is referred to as an event. So, there's some examples here. Shipment gets delivered, some kind of vehicle or something that you're tracking has a changed position. You've got a stock of inventory and someone is depleting that. You've got a staff member who is changing positions or has a different type of certification. Something is going on in the organization. And so if you think about event streaming, all it is taking these events, and the streaming part is modeling them in a way that they never end. You'll have this continual stream of events that are coming in. And so that is the concept of event streaming, that data is constantly going to be flowing in. And as it flows in, you need to act on it. So back in 2010, 2011, some really bright engineers at LinkedIn had a challenge where they were trying to figure out how they could deal with large amounts of data in the organization to create better experiences. They looked at all of the COT solutions, couldn't find anything, so they went out and they created their own thing. They open sourced it, called it Apache Kafka. So Apache Kafka is the de facto standard in the world. It's one of the most successful open source projects ever. And Confluent, the company I work for, was founded by those engineers who were at LinkedIn who originally created Apache Kafka. So when they released it into the open source, they started the company Confluent to be able to provide enterprise support and additional features and functionality above and beyond what open source provides. So Confluent still does 80% of the commits back to Apache Kafka, but this is the leading platform for dealing with data in motion. And so really quickly, don't want to get too technical, but the way it works is kind of laid out here with these different components. And so you start with the events, which we've already covered. So something happens, it gets encoded. However it gets encoded, you've got that information, you put it into a topic. So a topic is like a table in a database. You want that topic to be scalable though, so it gets split up into partitions, and a broker is kind of the brains for how all of that information gets persisted. So Kafka has a persistence layer built in, and Kafka is a distributed system. So you're going to have multiple brokers so that they can replicate that data and provide you fault tolerance and scalability. And the way the data gets in is through something called a producer. So they're APIs. If you're writing a program, it's very easy just to use that API and say, please send this information into Kafka, into this topic. Those events are stored then in order. So new events just get added to the end of that log. And it is modeled as a log. And so those producers can either use that API or they can use a connector. And on the opposite side, the people who want that data can subscribe to it and say, hey, I'm interested in the data from this topic. I'm going to use an API or use a connector that subscribes to that topic. And as soon as any information comes in, I'm going to get access to it. And so you can have as many consumers as you want who are all operating independently from one another to grab that information. But there is some key things here that make this architecture work. And probably the biggest one is the decoupling of producers and consumers. So remember, we were talking about how data in traditional architectures get shared through point-to-point connections. That means the people who produce it are directly sending it to the people who are consuming it. You have that tight connection. With Kafka, that goes away. The producers just send it into Kafka and they're done. They don't know anything about the consumers. Vice versa, the consumers just connect to that Kafka broker to grab the information, but have no idea about who produced it. So you have this decoupling. There's no reliance between a consumer or a producer. And because of the architecture, you can have insanely high throughput, but you still get things like strict ordering, immutable persistence. And because it's persisted, you can rewind and replay. So after you've grabbed something and you processed it wrong, you can go back and say, I need to grab that again. And so you kind of get the best of all worlds. So the scalability of a file system, the guarantees of a database, and the immediacy of a message queue, because as soon as that message comes in, all of your consumers who are subscribing to it get that message and they can then act on it, whatever they want to do with it. So that's open source Apache Kafka. Confluent has our own version, and Kafka, I mentioned, is a distributed system. Distributed systems are really hard to operate. And so Kafka's mission has been not to just make it far easier to run those things, but to provide a far better experience. And so we've done that by adding in additional functionality. I'll just go over very, very quickly. And the first is our customers need to run it everywhere, whether they're at the edge, they're on-prem data center, in the cloud, multiple clouds. They need an easy solution that allows them to do that and to have these different environments be synchronized together so that they can have their data everywhere. Confluent does all that. We've also kind of rewritten the core of Kafka to make it cloud native so that it can be elastic, resilient, be able to use object store, all of these great, amazing things. We've added a whole bunch of connectors because no one likes to write their own connector to be able to grab data out of Oracle, for instance, or push things into ServiceNow. So we have a bunch of connectors, so you don't have to write any code. You just use one of those. information goes in and out. Data quality is something that we talked about earlier, right? Knowing what the data is supposed to look like is critical, and knowing what data is actually in your system and where it came from is also really important. So we have a governance suite with a lot of functionality that allows you to do just that, so that as your data is coming in, you can apply the appropriate governance standards, security standards, so that you can trust the data that's coming in there. And then the last thing is, data is going to be coming in a lot of different shapes, and the raw shape may not be the curated shape that you want the consumers to actually have. So Confluent has a bunch of tools that are available to be able to take that raw data as it's coming in and be able to shape it so that the people who want it get the version that is right for them. So that can look like joining different streams of data together, transforming the data, serializing it differently, being able to aggregate it in different ways. So that is what you get with Confluent. So let's talk about how Confluent has helped some of our government customers with their logistics. So this unnamed agency has deployed our data streaming platform to modernize their logistics and operations from ship to ship, ship to shore, ship to cloud, and they have a really strong focus on supporting DDIL, the denied, disruptive, intermittent, and limited comms environments. So it was really critical for this customer to be able to have these mission critical systems stay synchronized and operational, even if the network connectivity, the network comms, fell out, they're unreliable, they're deployed, they're afloat out at sea, and so they need to be able to operate independently, but they don't want to lose any of that data, and they want to be able to still have that data be synchronized back to their cloud instance. And so Confluent does exactly that. So each vessel has an independent Confluent cluster running on it, which has all of the capabilities that we were talking about that allows them to operate alone when they are afloat. Importantly, they can also decide using some of our processing tools on an intelligent way of sharing that data back. So you can set priorities for the data to be sent back, because those comms can be in very limited supply, and they want to make sure that the most important messages are sent back. And so this is a very interesting use case that shows not just the capabilities of tracking where all of these vessels are, but actually what's happening on them. What are the logistics inside? What does the inventory look like? Is there enough toilet paper? All of these different types of things have to be tracked and can be using this type of a system. So another use case is for a large-scale mission-critical application for a DoD customer, where they have invested in an Oracle ERP system, but need to be able to connect to over 60 different downstream trading partners who need that information, some of which are internal, so that they can make the right decisions about equipment and staffing and other types of things. So the business value here is being able to take that data out of Oracle and present it as a reusable data product. So the type of a thing that all of these different trading partners can simply subscribe to, and to be able to do that in real time. So it allowed them to get rid of the batch-based processing that is very brittle and point-to-point and all of those ETL workflows. And they also were able to provide access to all of these different functions. So from analytics, being able to integrate with other types of systems that the downstream trading partners were using. It allowed them to have a business continuity platform that provided disaster recovery needs. And the final thing is it's scalable and flexible. So they have a lot of data going through this. This supports 1.5 million personnel's information, but it's designed to scale as needed. So if there are new trading partners that come online, if there are additional data products that need to be created, that can all be done without a major replatforming or licensing friction, anything like that. So it makes it very easy for them to be able to continue to grow. Another one is an agency that processes billions of events a day, and they have a bunch of information that has to be delivered across the country. And this agency had done a really good job of figuring out the strategy of data at rest. But they realized early on that everything that they were trying to do to create reusable data products in a lakehouse, in that at rest paradigm, they needed the exact same thing for all of the data in motion. And so they have a whole bunch of different operational applications run by different teams that track these events that show kind of the flow of information through their logistics system. And they needed a way to be able to take that and share it immediately with all of the different parties. And the way they've done that in the past is using custom extracts that would create files that would be sent over SFTP once a day or something like that. Or, for some of the more immediate stuff, they would use a message queue, but the message queue is really expensive and tough to handle the volume of data that they were throwing at it. And so once they adopted Confluent, they were able to solve a ton of their logistical challenges and provide the plant managers insights so that they could do a far better job with staffing. And Confluent is now being used as the platform for any type of data that needs to be shared in real time. It goes into Confluent, including data that needs to go to their lakehouse will flow through Confluent because it's it's already solved. You've already put data in there with the right security metrics. It's already been trusted. And so it's very easy not only to power your operational applications with that data, but also to power your analytical applications. And the last one is being able to track pandemics. And this one's interesting because it goes far beyond just federal, right? Because if you think, and this is, I think, a common challenge with some of the federal agencies, is a lot of the data that they need to be successful doesn't come from them. They rely on others, like state and local organizations to be able to feed that information in. And when you start looking at the types of data, the types of system, the formats, it becomes very challenging to kind of do a data call and grab information, let alone one that can operate in real time so that you can make decisions to be able to stop the threat of this. So Confluent was used to do exactly that, to work with all of this information that was coming in from all of these different partners. You can see many different pipelines were created to bring that data in so that you could provide these dashboards and insights into how things were spreading, how things were being treated, all of that kind of stuff, which would affect policy and be able to bring an early end to that. So there are a lot more examples of how Confluent and Kafka are being used to assist with the government. But if you're interested in, how could you, with your agency, with your program, get started with this if you're not already using some of it? I would suggest the first thing is a reframe, and reframe within your mind to start thinking a little bit differently about data and how you leverage it. So instead of tightly coupled point-to-point integrations, where you just kind of grab data, you throw it in a database, you do what you need to do, and then if anyone else needs it, you have a point-to-point connection to them, or vice versa. If you need someone else's data, you grab it from them. think about all of the people who could benefit from that. Because if you as a producer push that data one time into Kafka, you have served all of the people who are interested in it. You don't need to know who they are. You don't need to care about them. All you need to do is say, I have this data, it reflects these events, and here they are. That's part one. Part two, instead of trying to wrangle this data and cleanse it downstream in all of these other solutions, if you cleanse and curate your data as early as possible in that data pipeline stage, everything downstream will inherit your work. So making the investment to fix the data and get it right as it's coming in real time means that you're going to solve a ton of downstream issues with all of the applications that are leveraging that, including potentially your own. So the third thing, don't think about batch-based integration anymore. So think about a continuous flow of data that's always integrated and up to date. And then finally, don't think about querying your data as like a point fixed in time. Shift to a model where you're getting your reporting and you're getting your insights within milliseconds of when that data is actually created. Because as you do that, as you adopt these principles, you're going to be creating data products. And that really is the key to all of this. As you put data products out into the world, as other people put data products out into the world, you can work together to create new data products based off of those. So it becomes a virtuous cycle where it becomes very easy actually to innovate and to create mission value, because one of the biggest challenges, which is access to real-time information, is already solved. So you can focus just on creating the mission value based on that data that you have access to. And if you're creating new insights, push that out as a new real-time data product so that other people can take advantage of that. All right, so practically, what does this mean? I've outlined some steps here that we followed with some other customers. The next slide kind of shows architecturally how this works. But the first step in all this is you got to figure out where your data is and you've got to start integrating it, right? The second step is you got to create that real-time version of it. Maybe you don't want that raw version to go out into the world. Maybe you need to apply some security parameters and other things to it. And then step three is you want to replicate it, and you want to get it in all the environments where it needs to be. You want to be able to share it with downstream trading partners. And then step four, now that you have that challenge solved, you can create your real-time data product. So architecturally, if you go kind of from left to right, this depicts an edge and a cloud-based deployment that are working in concert with one another. So on the far left, you've got a bunch of sensor data typically, right? IoT that's generating information about what's happening with respect to your logistics. You need to take that data and bring it into Confluent. In this case, we're going to put it in the edge. So how do you do that? Well, we have a whole bunch of connectors and techniques for bringing that data in. So you can use a connector, you can use an MQTT proxy, you can write a custom interface, you can use REST. A lot of these IoT devices actually speak Kafka directly because it's so popular, so you can just go directly in. But the point is you'll have that second integration layer where you bring that data in to Confluent, and once it's there, you can start to process it, make it right. You can start to apply machine learning models to it, or take that and be able to enhance the models that you're already running. So the nice thing here is you can have access to a solution at the edge, which means it's extremely low latency and can be low cost because it doesn't have to go across the network to go up into the cloud. So you can completely power the mission from the edge itself with this type of an architecture. You can also deploy, and pretty much you'll always have this as well, a cloud or on-prem cluster that is going to work with all of these edge clusters. Because the edge clusters typically are going to be constrained by size, weight, and power. Those are some of the considerations in what you can actually do out at the edge. So for everything that can't be accommodated there, it needs to go to a bigger computing environment like the cloud. And so you can deploy Confluent in your cloud or on-prem environment and have those things synchronized together so that they can work in concert with one another. And the nice thing is, as you do that, you can have these things that will, these different data streams that can now work with each other. So it's extremely easy to create a new service that consumes from two different data streams and creates new valuable insights about your supply chain or your logistics so that you can figure out how you can be more efficient. And that can be done out at the edge, that can be done in a regional environment, and that can be shared wherever you want. And those can be, again, shared out as real-time data products. There are a whole bunch of things that you can do with this. So you can start to think about creating a digital twin to be able to run all sorts of what if scenarios to see what is going to make the most impact and make things more efficient by not making changes in production, but with that digital twin, be able to run through a lot of different scenarios. Predictive maintenance is a very popular one, right? Where you take the sensor data, you make it accessible, and then you can have all sorts of models that are running on top of it with machine learning to be able to flag, based on historical data, things that are starting to look like they need to be replaced. And obviously, preventive maintenance has all sorts of benefits by keeping things in service longer, being able to schedule the service so that you don't have the downstream impacts of things going out of service when you least expect them. So this shows kind of a centralized model where all of that is grabbed, but you can just as easily have some sort of a hybrid model where you've got a bunch of different facilities. They're all kind of operating independently with their own Kafka cluster. And then using our linking technology is sending all of that information to another aggregated environment where you can do even more. And so we've done things like that where, we can create, in very short time period, I think this was less than a day, taken data and just thrown together a GUI on top of that data to show what an example preventative maintenance dashboard would look like for the specific customer. And so the best part is you get to choose with this where you want the insights to be created and how you want them to be shared. And so if you have this DDIL operation, Confluent can absolutely cover that. In fact, the next tech talk that we do is going to dive a lot deeper into how that works. And we can even talk about something that runs as small on is something as a soldier itself. You can have the edge be a soldier that is wearing a device that collects data that operates independently, but can be linked into a command post and then beyond from there. So in conclusion, hopefully this has been helpful in teaching you how Confluent can help solve some of these logistical challenges that we talk about. So how we can get that real-time visibility with data that we trust, how we can have a solution that can scale like crazy and be reliable enough for these mission-critical workloads, how we can have legacy and modern systems working in concert with one another that are just sending all of their data into Confluent to be able to share that out, and then being able to support workloads wherever they are. And so there are a ton of different applications for this. There are some here, but man, there are so many more that could be done specific to logistics. But looking more broadly at the public sector, this type of technology is extremely applicable. And so if you have any questions about these types of things or about that in general, would love to talk with you. And with that, I would love to dig into some of your questions.
All right. We do have a question in the chat box. The first question is, how does Confluent integrate with legacy logistics systems commonly used in state and federal supply chains?
Yeah, great. So this is something that we covered in the presentation a little bit as well. But one of the great things about Kafka and Confluent is the ability that they have to easily integrate with any kind of incoming data. So I always refer to this solution as the Switzerland of data. So it really doesn't matter what kind of legacy solutions you have. What you'll have to do is you have to look at what sort of capabilities those legacy solutions have for being able to share data. And typically that's going to be the constraining factor. And so Confluent offers a lot of different connectors and other utilities and patterns for grabbing that data. Depending on what the legacy system is, they could be able to just push it in directly, or you would have to write some sort of an adapter, perhaps that's just specific to the capabilities that that legacy system has. But the nice thing is when you do that once, because of the nature of Kafka, you can serve all of the different downstream consumers of that. So that pain is something that is kind of short-lived and lives on with the greater benefit for the rest of the organization, since now they have access to that information.
Thank you. We do have another question in the box. What are the biggest challenges agencies face in gaining real-time visibility across distributed logistics operations?
Yeah, so this is a really good question. So I think for me, the biggest challenge is just having the will to define that kind of a solution and creating that as a priority. So if they aren't looking for, or they don't have some sort of a real-time data platform to assist them, it can be very difficult, right? Because what ends up happening is technically, if they go forward and try to do this, they will look at all of these different data streams. They'll try and bring them in to some sort of system that uses point-to-point connections, stores that data at rest. And what they build is something that is very brittle and cumbersome to be able to operate. And so it may be successful in the short term, but the long-term viability of that comes into question just because it's very difficult to operate those kinds of solutions.
Thank you. And we do have one more question in the chat. Can you share an example of how real-time event streaming improved operational readiness or response time in a logistics use case?
Yeah, absolutely. So there are a few that come to mind. One of them I'll probably just have you look up on your own. So if you do a Google search for, there's a program at the Postal Service called Informed Visibility. And the Office of Inspector General did kind of a retrospective of that program, which is supposed to provide visibility to what's going on within plant managers and different facilities. So you can go online, search for this. They did a report, and there are a whole host of different benefits that they found from better communication, saving costs, having better access to data, being able to staff the plants that they had more effectively. And so all of that was due to the adoption of data streaming and changing their paradigm of how they were dealing with their real-time logistics data. So a very interesting use case. Improving operational efficiency using informed visibility. Do a Google search for that, and when you got some time, take a look.
Thank you. I do not see any more questions in the Q&A box or in the chat. Would anyone else like to submit a question? No? All right. I think if you do have a question, please submit them to us either at the end of the session, you can respond to us via an email. I will be sending out the recording after this. We do want to make note that we do have the next session scheduled for August 14th, and we will include a registration link for that as well in the email communications. Thank you, Andrew, for your time today. We appreciate you being here and for the valuable information that you gave us, and we look forward to the next call.
All right, thank you.